The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. My name is Susana Tomás, and I'm part of the marketing team of CW Group. I would like to welcome you to the CW, Voltalia, and Burdenberg collaboration webinar. Thank you for taking the time for being here with us today. It is a pleasure to host you. First, I would like to say a few words about our work here at CW. CW Group is a leading business intelligence boutique with a global track record that works within three branches: research, advisory, and media. A significant part of research is the studies that focus on cement demand, country reports, historical as well as forecasts for markets in a variety of products, including one of our main products, the VFR, Volume Forecast Report. Also, we provide commodity prices assessments for cement, clinker, as well as petcoke and coal. The advisory part of CW focuses on working with major global consultancies and leading institutions, providing a diverse product portfolio from the scope of consulting and advisory, as well as helping with strategies, project management, and market assessments. The media part, however, offers a vast database in premium newsletters that focus on cement, coal, petcoke, paper and pulp, bulk, and building materials. For more information, please feel free to contact us. Now, I would like to introduce Mr. Paul van der Boek, Market Intelligence Manager at Voltalia. Mr. van der Boek will act as the moderator for this discussion and will introduce our two main hosts of today's event. Thank you for your attention.
Hello everyone and welcome to this webinar. I'm really happy to be kicking off this session. Warm thanks to you, Susana, and all the CW Group team for hosting us today and giving us this great opportunity to be connecting all together for about an hour and discussing a very interesting topic of renewable electricity for large industries. I am Paul van der Boek, Market Intelligence Manager at Voltalia. We are a renewable energy producer headquartered in France, and you will know a little bit more about us in the next minutes. I will be moderating the questions after the presentations from our speakers today that I will introduce now. Gustavo Fernandez is the head of international development at Voltalia. He will introduce a little bit about the company, but we'll be focusing on explaining why industrials, heavy industrials, are increasingly looking at procuring renewables for their supply. And he will explore further the new relation that emerges between heavy industrials and renewable energy producers for customized solutions. Conrad Purcell is a partner for energy utilities at Burdenberg, a renowned international law firm. He's based down in London, UK. He will also tell us a little bit about his experience in negotiating PPAs and other types of agreements between renewable energy producers and industrial clients. I will now give the presentation to Gustavo Fernandez, who will start explaining about this topic. Gustavo, the floor is yours.
Thank you so much, Paul. Good morning or good afternoon to everyone that is joining us today in this webinar. It is really a pleasure for me to be here present today. As Paul mentioned, my name is Gustavo Fernandez, and I am the head of international development in Voltalia. Let me start this conversation today and explain to all of you a little bit about Voltalia. As Paul mentioned, Voltalia is an international company present in many different countries with a focus in the renewable energy sector. We work with multi technologies, from solar, wind, hydro, biomass, and storage in a multi-country from Europe, many different countries, up to Africa, Southeast Asia, Japan, and on the other side to Latin America, with a strong presence in Brazil, Colombia, and Mexico. Our main activity is as an IPP. So we complete the full development cycle from the identification of the different needs of a project, from land, interconnection, up to taking care about all the permits, license, and agreements. And of course, found the different off-takers of the electricity that can be public and private. And at the same time, because we understand that the market is also demanding, and some companies prefer to do the investments, or some of our clients prefer to do the investments by themselves, we can also offer services from the development up to the construction, execution, and operation and maintenance of these same assets on behalf of our clients. Today, as I mentioned, we are present. We have a strong international presence. We are around 1,100 employees all around the world, and our current portfolio of projects, it's around 1.3 gigawatts, with a strong in our balance sheet, with a strong pipeline, as I mentioned, in Latin America, with a strong focus in Brazil, but at the same time in Europe, Africa, and Southeast Asia. That will probably most part of our presence will match with the presence of the companies present here today. Since and probably most of you follow a little bit about this renewable energy sector, I would say that up to 5-6 years ago, most part of the projects are following what we call the feed-in tariffs that are really important for the sector to mature the technology, to mature the business models, to mature the contracts and the experience of the different stakeholders around the business. But since 2013-14, the corporations and the industrials start looking to procure directly the renewable energy, or to buy directly the renewable energy from the IPPs, company like Voltalia. And since that time, we have been working with different companies from different sectors, as you can see here on the right side of the screen. Companies like Telefonica from the telecommunication sector, up to Auchan, Decathlon for the real the mass market products, up to banks, Crédit Mutuel, LCL, up to rail companies, even cities and municipalities that are procuring directly, up to industrial or big industrial companies like Braskem or VRF. And these are just some of the references that we have to share here today with you. So far, we have executed around 600 megawatts of contracts in this corporate PPA modality. And in average, these contracts have a duration of 20 years. What is important from our side is that we can be flexible. We can adapt to the needs of our clients. This means that we can do on-site projects, or we can do off-site with private wire or indirect connections to the facilities that are consuming. We can do off-site, taking wheel projects and wheeling these the electricity through the network. We can also, and due to our experience, we can have a mix in between different technologies and adapt in between what is solar or wind, storage, biomass, hydro, to adapt to our client needs. And of course, in the end, we also need to adapt to what is the framework that we have currently in place in each one of the countries. And that for that, we have a team that will study and will implement the best contract and best framework in order to deliver the electricity that our clients need. as I mentioned, since 5-6 years ago, we are seeing that the intensive consumers of electricity are procuring more and more the solutions and coming from renewables. And the main reasons that we identify in the market about that needs, and from the conversation that we are having with the multiple clients that we have, is that from one side, electricity in some sectors could represent a very high share of the OPEX. This means that the product that they are selling includes a very high percentage of electricity. And unfortunately, the prices, the electricity prices are increasing, or the trend is to increase. And most important than that is the volatility that we found in the market. So as most of you have experienced during 2020 and with the COVID, the prices are due to the lockdowns and the confinements that everyone is suffering. Prices are going down, but immediately when the economy starts to grow, the prices are coming again to very high values. And the renewables could bring this stability in the prices over the 20 years, because the fuel in this case, it's coming for free. It's the sun, or is the wind, or is the water that we are collecting and transforming in electricity. Another important angle, it's about in some countries, and this is more to emerging countries like in Africa, where we have many situations that our clients are suffering from unreliable supply, and we can develop solutions where we can fix this and produce on site to deliver to them the needs and the reliability on the supply. On top of that, we also see that it's more and more important the sustainability of the economy with the binding carbon targets in some cases that are affecting the cost of each one of the factories and the products. And most important than that is that our consumers today are much more aware about the sustainability and are demanding for the products to be sustainable regarding the future developments and the future of humanity. For your reference, and I believe that most of you have been following these situations, that the carbon prices are getting higher. We start the year with prices going up to around 50 euros per megawatt hour, per ton. And as you can see here, the expectations and projections from Bloomberg is that these prices could range around 100 euros in the medium scenario, in the base case scenario, in the end 2030. This could have a big impact for sectors as iron and steel, or cement, or chemicals, as they have very high emissions coming from their cycle of production. And we can see that already some of the main players in this sector, and this is just some examples of companies in this sector that are already committing to targets, important targets, because everyone understands that that sooner or later everyone will need to pay for these CO2 emissions. Okay, sorry, this is too fast. On top of that, we are also seeing the decline of the cost of renewables. So today, renewables, or any electricity that is produced from solar, from wind, are coming down, and you can see here the reduction of the cost that we may have, that we are having from the last 10 years, 11 years in the sector. At the same time, as I mentioned, we start seeing the incredible trend growing on the procurement of the different companies, especially on the heavy industries, on the renewable energy sector. We can see a very dynamic market in many different countries, and some of the companies covering 100% of their needs from clean electricity, of course, in more mature countries. But we see this trend, and as you can see here, the objective or the projections until 2030 are with a stable growth over the coming years. And the main option, or the preferred option for many of the industrials with whom we are discussing, it's to go on the PPA. PPA means power purchase agreement. That is a contract established in between the consumer and the companies like Voltalia that are producing this electricity from the different technologies. But most important than this initial introduction is what can we offer to you? And what we can offer to you, it's four important pillars. That first is the possibility to have a price security, the stability of the prices on the electricity sector over the coming years, and not to be facing the up and down if you buy directly in the market or if you have a contract with the utility. And this is important because you can have a long-term projection about what will be the price in the next 20 years. We can also bring the sustainability and helping you to achieve the CO2 reduction targets with the inclusion of renewables in your portfolio of electricity consumption. We can offer reliable technologies. This is very important for countries or for situations where you are depending on unreliable grids or companies, especially in emerging countries where we are facing many blackouts or load shedding, as some of the countries in Africa. And with renewables and on-site production, we can have a continuous supply of electricity. And finally, we can customize our solution to each one of you. We have a dedicated team with more than 1,000 people just thinking and helping our clients to have this price security, to become more sustainable, and to have reliable power to supply their needs. Just a little bit more of introduction to what is the different ways that we have to the different configurations that we have to do our power plants with renewable technologies. We can have what we call the on-site or captive or behind the meter. That is similar concepts. This means that the facility that will produce electricity is located inside your premises, inside your industrial facility, and we will have a direct connection to your consumer center or to your consumer point. Only opposite to this, because some of your industries are not or don't have the right space, enough space, or they have some other issues that will not be able to accommodate the enough capacity to produce the needs behind the meter. We also offer what we call off-site or in front of the meter that are not co-located with your facilities. So we will work with the national utility or the transmission company and distribution companies in order to provide you the electricity and will to you the electricity that we are producing in a different place inside the country or inside the same region. This is just a little bit more about the graphical example about how can we work. So this is behind the meter on-site configuration, where we have an energy management system that can play and can organize your consumption coming from the renewable energy plant, or in cases that you have a thermal generation plant, if you are connected to a reliable grid. We can also add storage and manage the consumption coming from the grid. This is what we call an hybrid solution, and we can guarantee you a continuous power supply 24/7. On the other side, the off-grid configuration, as I mentioned, we will use through agreements that we will do with the utilities or with distribution companies, and we will negotiate with them the wheeling and balancing contracts, of course, always according to the regulation in place. And we can offer to you a package with a fixed price or with a variable price according to your needs, in order to feed your industrial load. In some cases, it's also important to mention that in some cases, and according to each of the regulations that we have in place, we can sell the surplus to the local utility. But this is case by case. We can also, on the commercial side, we can also, according to your needs, we can have two different models. The first one is what we call the IPP model, where we negotiate with each one of our clients a contract. This contract we call the Power Purchase Agreement, or PPA. And in some other cases, as because of the regulation don't allow, or our client prefers a different business model, we can propose a leasing model where we lease through a lease contract, we lease our generation system that will feed your needs. Just a brief examples about what is happening in this cement sector. You can see here that we have already some of the industrials in this sector already with projects, namely in some countries that can go from Europe to Africa, Latin America. So you can see here that it's possible to do these things in multiple countries, and with different multiple sizes of the projects. Finally, I would like to explain a little bit how can we work with you, and on a case study. So basically, what we need from you, it's your inputs, your needs, and this is coming from your monthly energy consumption numbers that you have, your electricity bill, to understand where you are located, if you have or not have area available. And then through our engineers internally, we will design and offer to you in a solution the best mix of electricity to maximize the incorporation of renewables in your consumption. And of course, we will understand what will be the area needed around your facilities, or if it is in off-site, the area that we may need. And we will offer to you the price, the PPA price, that usually is defined in euros or dollars or any other currency per megawatt hour, and the cost savings that you may have from the utilization and the increase of renewable energy in your consumption. This is just a little bit of a schematic and visual understanding for you. For example, in this case, we have the industrial facility, and we have on-site generation with a solar PV plant that will be connecting directly to the substation that is feeding our industrial facility. Just to give you a brief understanding, usually we can see savings in your bill from 2 to 7%, depending a lot on your profile, on your prices, and your needs. So this is what I want to say to you today. I will hand over now the camera and the mic to Conrad, that will give you a regulatory perspective about all these important aspects.
Thank you, Gustavo. I'll just like to tell our attendees that they can ask as many questions as they want. There is a menu questions in the GoToWebinar platform, so feel free to write your questions there, and we will collect them and provide answers after Conrad's presentation. Thank you very much.
Thank you, Paul, and thank you, Gustavo, and many thanks as well to Voltalia for allowing me to join and participate in this presentation today. very briefly, a bit about Bird & Bird. We're an international law firm. As Paul mentioned, we have 30 offices around the world and about just over 1,300 lawyers. And certainly from a sector-focused perspective, the renewable energy world is something that we've embraced, and I personally have worked on renewable energy projects for over 15 years. So this is an area which we're heavily involved in, very interested in, and also experienced in. Moving to the next slide, if I click on here. I'm not sure. Oh, here we go. Sorry, I've gone too far now. So I'm going to pick up on the points made by Gustavo. So if I can get to the right slide, here we go. And really, the key aspect of this part of the presentation is to pick up on the different models that Gustavo was talking about that can be used in order to procure the electricity that an industrial user might want to engage Voltalia as an IPP to provide to it. And if we focus in particular on sort of emerging markets where the regulations are less well developed in terms of unbundling of utilities, and in many cases you still have state-owned utilities, so state-owned electricity companies who wholly own the assets relating to power generation within that country. And from a protective point of view, the state in many places will historically have sought to protect its utility from cannibalization by others of its business and prohibit the kind of independent power production that's being described in this presentation. So at its most stark, we have the first example in this bullet point, which is that you have regulations, for example, in, say, Ethiopia, that prescribe that a private company cannot supply electricity to a third party, and it cannot own any generation assets other than for self-consumption. So you would be allowed to have a diesel generator, or you would be able to have a solar park within your own premises to provide you with electricity for your installation, but it wouldn't be possible for you to engage a third party through a power purchase agreement to provide you with that power. Now, in that case, there are still solutions that allow for structures to be developed that don't breach the regulations and achieve the outcome which is closest to what Gustavo was describing. So the first example, if I can give of that, is where you have the deferred consideration model. Now, under that, Voltalia in this case would procure, finance, and build, say, a solar park for the industrial user, so you. They would then transfer title to that park because the regulation prohibits a third party from owning the generating asset, but it wouldn't prohibit you from owning the generating asset. And that would be done upon commissioning. And then the cost of financing the original construction, the capex, would effectively be amortized over the life of the project and paid by way of a fee that would be the operation fee payable to the entity, so Voltalia, who had initially procured the development of that and also put it in place on your site. So it would be a workaround from a regulatory perspective. It does unfortunately cause some difficulties from a financing perspective, because it's not possible in that case for the funders of the project to take asset security in the way that they would ideally do. So that has to be structured around, because you would own the asset as the industrial user rather than Voltalia continuing to own it and just selling you the power. So those are the most difficult and challenging set of regulations, but it's by no means the case across, certainly if we take the continent of Africa, there are very many different regulations in different jurisdictions, and in fact sometimes even within one country. Because the important thing, of course, always to remember with this is that power, like water, is political. So in many cases, the drivers for those kind of protectionist regulations will need to be understood in order to practically see what's possible on the ground. And the second example that's given here of regulations that prescribe a private company from owning generation assets might well mean that you end up in a situation where ownership has to vest in one entity, the one that's using the project. So in those cases, it might say that Voltalia can own a generation asset, but they can't supply electricity to a third party. Now, in that case, that there is a different solution that can become about here, because what you would say, in effect, in that regulatory context, is you would say Voltalia owns the generation asset, and they're not supplying you with electricity, they're leasing the equipment to you so that you can supply yourself with electricity. And of course, Voltalia, as part of that package then, would assist you with the process of supplying yourself with electricity. Now, it might seem like a very fine distinction, but the key point, very importantly, from a funder's perspective, is that the asset remains with Voltalia. They're only leasing it to you as the industrial user. And from that perspective, it makes it much easier for them to fund the capex of that project. And again, then, the capex is amortized over the course of that rental or lease agreement, so that you end up with the service and leasing fee effectively covering the cost of the development and operation of that asset. And then the third example we've given here is the kind of example that you'd see more commonly in a developed OECD type market, where it says that a private company can own a generation asset and it can supply electricity to third parties. So, for example, I can build a wind farm or whatever it might be and sell you the power either directly or through the grid. And now that's the most typical model from a project finance perspective. It's not as straightforward as it sounds. There are still licensing requirements that have to be complied with. So, for example, it's common that supply of electricity to a consumer or to premises is a licensed activity, and in those circumstances, it's common for that PPA to be what's known as sleeved. So you involve a utility to help sleeve that PPA because they are then the licensed supplier. But that changes in different countries around the world. However, from a bankability perspective, it's a much easier model for Voltalia to provide to you. We try and get to the next slide without overshooting. Apologies, these are a little slow. Here we go. So we're looking at grid connection then. You may recall that Gustavo described two models, effectively in front of and behind the meter. So the private wire supply is effectively where you avoid using the grid. You don't need a grid connection, and you have a wire that connects the plant literally to the industrial user. Now, regulations in country will also dictate how attractive an offer Voltalia is able to provide to you here, because it can be sweetened from the industrial end user's perspective if, for example, you're able to wheel any surplus power. So if you have a 100 megawatt installation, that's a lot of power for an industrial user, and they may have two sites within a given part of a country. Now, you may be behind the wire for one site, and where there's surplus generation, you may wish to then use the grid to wheel that excess power to your second site. And where wheeling is permitted, wheeling means using the electricity grid to carry power to your other site. It's not literally the electrons from that solar park or wind farm that are carried to the distant site, say on the other side of South Africa. But it's a balancing pooling type arrangement whereby the electrons that are put onto the system by your generating asset can then also be used across the system, and an equivalent amount subject to line losses. There's a calculation for line losses, and an equivalent amount can be used at that distant site. An alternative is net metering, which is the alternative given here, where again, if you're generating surplus power from the site, more than you can use or that you need, if you can sell that power back or balance your so net metering refers to balancing what you import from the grid with what you export to the grid, then that net amount of electricity used is reflected in your electricity bill. And of course, you will see a greater saving if you can sell back the excess power that you don't need yourself to the grid company. And so the desirable set of regulatory drivers that you would hope to see there is that private companies can own generation facilities and supply electricity to third parties. So that would mean Voltalia is able to own the asset that it's built and then sell you the power under a PPA. Wheeling and net metering is permitted. So say in Jordan, for example, that's a good example of where wheeling is permitted, despite it being a relatively complicated regulatory landscape. And that then allows the use of the grid to give you a wider range of options for the development of projects. And then the third is the ability to sell surpluses to the grid company, which of course optimizes efficiency and means that there's no waste of excess electricity that's generated. And then onto the final slide, quickly again talking about site surpluses. Now, if we take examples of specific individual countries, where exports from site under a net metering arrangements take place on a given period, ideally, what you would want is a regulatory environment that permits you to take a view over a period of time, so that it's not the case that you know, if you export some power to the grid on a Monday and a Wednesday, that if by Friday you haven't used an equivalent amount, then you're not able to net the two off against each other. By banking those exports for a period so that you can take the net amount of electricity that's been imported from the grid and exported to the grid over, say, a 12-month period, that allows you to have a much more balanced view of the economics, and also to take advantage of cyclical changes over the seasonal variations within a given environment, so that if you're drawing relatively more power than you're able to spill into the grid in the colder months or in the darker months with shorter days, that can be offset with the excess when there are longer days during the summer. And then finally, with regard to wheeling, as you would expect, it's a service that has to be paid for. So we see this across the United States and also in many other countries where there's a wheeling charge which is payable. And of course, that's there to help to pay for the cost of the infrastructure which is being used. But having the ability to use the grid in order to be able to effectively transport the power notionally from one part of the country to another is extremely useful. And it allows Voltalia to be able to offer to you the optimum scenario, potentially, where there's a site with all of the characteristics required for grid generation in one place, but it's quite a long way removed from the physical location of the industrial installation, the cement plant, for example, that you have elsewhere, perhaps close to a dock or something where there's less availability of land. And really, in relation to that, what you'd also be looking for there, what Voltalia will be looking for on your behalf, is transparent regulations that include a relatively simple and straightforward connection process with grid connection agreements and sleeving arrangements, so that there isn't a prolonged negotiation required each time. They're obviously experienced at this, but it's simpler where a pro forma set of documents allows them to just be able to plug in effectively a plug-and-play solution, and that's something which will help them to be able to offer that kind of solution in some countries in a way that would be more difficult in others. So that's it from me. I should hand over to Paul now, because I think the Q&A session will be moderated by you, Paul.
Thank you so much, Conrad, for this very insightful overview of regulatory issues. I think we are now ready for taking some questions from the audience. We have received a few here also before, prior to the webinar. So I'll just start with a topic that has been addressed in previous questions. It's about storage, and more particularly battery storage. We are seeing more and more projects with the decline of cost of batteries, including this type of technology. I will start maybe with you, Gustavo. What do you think would be the the conditions for storage to be competitive, to be viable in such a project for an industry. And I'm mostly focusing here on on-site projects, which can benefit from storage, as you mentioned in your presentation.
Okay, thank you, Paul, for yes, for this question. And the audience, I think with all of you in the presentation, the decline on costs of renewables over the last 10, 15 years, and today's in proportions. What we are seeing to decline with the same in storage with batteries. I will be saying that if we are in emerging countries where the grid is not stable, with probably the industries consuming from thermal generation, if it could be HFO, diesel, or thermal combustibles, the solutions with storage can be and are already competitive. When it comes to individual solutions that are in countries in US, I would say that we are a little bit yet not far, but a little bit far from the solution to be competitive. But I think in the next 3 to 5 years, storage will be becoming the mainstream technology, and together with solar or wind, we could offer very competitive packages, and very competitive comparing with the actual costs of electricity that the industrials or the big consumers can buy and acquire in the market. So I'm quite confident and positive that in the coming 3 to 5 years, these technology storage will become mainstream and be very competitive in terms of comparison with the existing or the prices from the grid. I think, Paul, that we lost you.
While Paul is frozen, Gustavo, maybe I'll just throw in a quick comment there in relation to battery storage, which is also that from a regulatory perspective, we're seeing countries around the world are having to wrestle with how they treat battery storage projects with regard to the label they attach to them. So is it described as a generating project, in which case a certain set of restrictions and limitations will apply to them, or because truly they're not obviously generating net additive electricity, what they're doing is they're taking power from the grid, storing it, or taking power from a renewable installation, storing it, and then dispatching it later, whether there should be a relaxation of some of the restrictions which apply to generating assets. We're seeing, for example, in the UK, that BEIS, the relevant department for energy, is considering that and has recently consulted with industry on how they think that those regulations should be changed. And of course, from a competition perspective, you're absolutely right, Gustavo. I mean, whether or not batteries are competitive will depend on a range of things. I mean, if you're looking at co-location with someone who's got a diesel genset or is burning HFO, the cost of getting HFO to a remote part of Namibia is extremely high, and that's going to be a different outcome then compared to someone who's got a grid connected plant and they want to have backup to deal with the unreliable grid.
Correct, thank you. And on top of what you are saying, storage and batteries can also bring another set of what we call auxiliary services that can be remunerated and or stability to talking about, namely, can offer degree frequency and voltage control, reactive power on top of the store the electricity and accumulate and to what we call power shift.
I think we have some people who have raised their hands on the platform. I'm not sure we can share the microphone. So if you want to ask a question, please write it down in the questions menu. I hope it's easily doable for you and foundable. It should be below the window. Conrad, you mentioned that in some countries it's already possible to negotiate power purchase agreements or equivalent when not exactly under this format. What would you say are the main clauses that an industrial company should pay attention to negotiating a PPA with a power producer? Are there any specific clauses that are being specifically challenging?
Well, without wishing to suggest that there are certain points that people should be picking up on their contracts with Voltalia, I can tell you where the concerns would be in order to make a project bankable, should we say. So what many industrials will really appreciate is that Voltalia can provide them with a project which is both developed and funded and built. So that means that all of those aspects are taken out of their hands. Now, in order for Voltalia to be able to do that, it'll be necessary for them to demonstrate to their funders that that revenue stream, which is coming under the power purchase agreement, for example, has certainty in it. And there are concerns which are often raised from the perspective of industrials around, certain scenarios relating to risk, which is not controlled by either party, where there may be circumstances in which it's outside of everybody's control, but there, either is an interruption in the delivery of power, or there's a change in law which affects the basis on which power can be delivered by Voltalia. And careful examination or careful analysis should be carried out of those clauses in particular. Obviously all of the clauses are important. You need to look at pricing and duration and what the various conditions are in terms of service delivery. But really, when looking at things like change in law provisions and what the consequence will be of a change in law, ultimately, Voltalia's lenders need to be sure that there is a revenue stream there which supports their lending to the project. And that means that it's only possible to negotiate so far under a power purchase agreement with an industrial in a way that would give the industrial optionality. They do need to accept that the benefits of a long-term power purchase agreement might mean price certainty and certainty for the industrial in a way which frankly puts them in a better position than many retail consumers would be. A large industrial or a tech company like Google can buy electricity much more cheaply than you or I can at home, because we don't have that same kind of leverage in the market to be able to buy power from an IPP like Voltalia, who can effectively give it to us cheaply from a wind farm. And we have to buy it through the wholesale market. But the flip side of that is that you are then locked into a 20-year agreement. And of course, that's going to be more suitable for some projects than others. If you have a mining operation and that mining operation has an indeterminate period before you exhaust the resources of the mine, it may not justify the capex associated with a large project, in which case you would then perhaps look at co-location of solar and HFO rather than going solar and storage. It would change the dynamic, but there should still be important benefits that can be obtained even over a relatively short period of time. And Gustavo will be able to tell you more about it, but I think one of the key things there people are looking at now more and more is use of mini grids, and how that mini grid solution with what they call the anchor tenant model. So the industrial, say, cement factory would be the anchor tenant supporting a mini grid, which then allows both for the sale of surplus power, but also it helps to mobilize that social license, which is obviously so important in many countries where you have activities like mining or cement production. If you can then show the benefit to the local community through a mini grid structure as well, that helps with all of the activities that company is doing locally.
Thank you. It's very clear. Gustavo, any other take on that?
No, I think that Conrad describes precisely and very well the conditions and what is important for the projects to move on.
We have a question here. What is your pick between solar and wind for reaching carbon neutrality? I'm guessing that this is a tricky question. We have seen a lot of wind PPAs in the beginning of this trend in mature markets. Now moving quickly to solar, in addition to wind. In on-site projects, we have seen mostly solar solutions, if I'm not wrong, for questions of space and land and resource. Would you say wind has a role to play on on-site solutions? Have you seen any deals mixing between wind and solar as a hybrid solution?
Yes, definitely. I think that the question on the wind, it's probably more focused, or what we don't have seen on-site wind. It's because of the local restrictions that you may have, as the industrial areas are usually close by residential, and then we need to fulfill with certain conditions with the visual and noise impact. But I have already seen, for example, here in Portugal, where I'm located, we have already some factories, for example, automobile factories that are putting on their premises big windmills, and they are consuming directly from that windmills. What I think it is important is that if these will not collide directly with the environmental and social restrictions that you have in place, namely affecting the neighbors' population that is around the industrial facilities.
Great. In terms of technologies, maybe that will be our last or one before last question due to the time that is running. Hydrogen, of course, is a very discussed topic at the moment. We have received some questions prior to this session as well on this technology. Would you like to give a few words about how hydrogen can play a role, especially for heavy industrials that can use green hydrogen into their processes?
Thank you, Paul. Maybe I can take, and then Conrad, I will also give you some space to talk about a little bit about the hydrogen. This is the hottest topic probably today in the sector. What we have seen, it's and what in my opinion, what it makes sense, it's to have these hydrogen generation facilities close by the industries that need the hydrogen or other correlated green molecules. Hydrogen, we have many other green molecules that can be produced using renewable energy, and what we see, for me, it makes all the sense that we have co-location of the capacity to produce this material to be included in the industries that need hydrogen, included or their industry or any other green molecule as part of their raw material in the industrial process. Today, I think that the industry also needs to the hydrolyzers that are still very early stage of development. When it comes from the renewable energy producers like Voltalia, we are quite confident that the renewable electricity that we could produce and we will produce, it will be provide the green hydrogen or the green ammonia with very competitive prices compared today with the other ways to produce hydrogen. But we are seeing today that these early moves. I know that especially in Europe, a lot of the buzz is around this sector. I also know that some countries are starting to implement some, let's say, tenders or auctions for this technology. I don't know, Conrad, from your side, if you have been involved in some of these or some of these technology.
Yeah, so in fact, the first hydrogen project I worked on was a few years ago, which was a co-location of hydrogen as a sort of a historical add-on to a wind farm, and that was on a Scottish island. Now, there were very particular circumstances around that made it viable. It was a test project, and certainly it needed support from public funds to make it work. But it was a kind of a viable proof of concept in that you had a wind farm generating electricity which was in excess of what the constrained grid could take away from the site. Co-locating an electrolyzer or retrofitting an electrolyzer to the site to take that excess power to then create hydrogen on Chapince itself has resulted in a little local infrastructure where there are now vehicles that operate on hydrogen, and more importantly, a ferry. So there's a ferry that carries people from the island to the mainland, and that's run on the hydrogen which is generated on the island. So you have this sort of little circular economy, if you like. The big issue, which, you know, I totally agree, hydrogen is the current hot topic. It's all anyone's talking about. But I really do struggle still a little bit with the round trip efficiency of using renewable energy to generate hydrogen. You lose a lot along the way. And when we talk about, you know, injecting green hydrogen, especially into the grid, potentially to help to provide a solution for the decarbonisation of heating in the UK or elsewhere, when you look at the round trip efficiency of taking electricity, converting that into hydrogen, and then injecting that hydrogen into the natural gas grid in order to provide a low carbon solution to heating, I think it forgets why we use gas in the first place. The reason we use gas to heat our houses now is because it's so much cheaper than electricity. I mean, it costs much less. It's a huge amount cheaper. Now, to therefore use electricity to create hydrogen to inject into the gas network to provide gas for heating misses the point as to why we use gas in the first place. Now, all of that said, yes, I'm sure there will be good examples of this. I've not worked on any recently, but I know that there are you know, developers and people looking at projects, for example, in Northern Australia. They're looking to do large solar projects there, which will then convert use solar power to power electrolyzers to convert water into hydrogen and oxygen. And there are theoretically plans then to export that to Japan. And you know, you will all have seen various stories about proof of concept designs for ships to carry either ammonia or you know, high pressure hydrogen across to the Japanese. You know, I suspect that a lot of the areas that need to be decarbonized could be decarbonized more effectively by going electric rather than to hydrogen. But there are, of course, certain circumstances where we need hydrogen, and then I guess the decision will come between, do we have green hydrogen or do we have blue hydrogen? So we have hydrogen from natural gas, but we capture the carbon or the methane. And it may be that that's actually the cheaper and more efficient way of doing things, but it's certainly fascinating times.
Thank you, Conrad. I think it's almost time for us to close the session. Just maybe a perspective question to end with. We have a question here about power prices. Do you think they will continue to go up or down in the future? What's your take on that, Gustavo?
I don't have any crystal ball, but I will say that the power prices are very related with the carbon prices. And what we see is that the trend it's moving up, as I mentioned, and I share the projections for 2030 that the carbon prices are going up to maybe 100 euros per ton. So what we can expect is that the prices continue to move up, namely on what we have today on spot markets. And that is one of the advantages of renewables, that we can provide stable prices over the long-term perspective, as we are not subject to such taxes and provisions that we have today in the market.
Thank you. So I hope the session was insightful to all our attendees. I would like to thank you warmly, Gustavo and Conrad, for presenting these very interesting facts from your experience. I think the session was very good, and I'd like to thank once again CW Group for hosting us and allowing us to present these interesting trends and insights about the renewable energy sector. Our contacts from Gustavo and Conrad are indicated in the slide here. If you want to note them down, we are available for any further query or question you would have about what was presented today. Also, I think the CW and the organizers will send you the presentation from today, and the session has been recorded, so you will be able to visualize it after we close today. Thank you very much again. Gustavo, Conrad, if you want to give any final word.
No, only to say thank you both, and it was a very enjoyable session.
Same on my side. Thank you to everyone for being today with Voltalia and Bird on this interesting session.
Thank you very much, and have a good day and week ahead. Bye.
Thank you. Bye-bye.
Thank you. Bye.
In the name of CW, I'd like to thank the two panelists and, of course, Paul. Thank you so much for participating in this insightful discussion, and have the rest of a good day. Thank you.